and good afternoon everyone. Today, our group will be discussing about infrared radiation technology in thermography. For the introduction, infrared thermography is a non-contact temperature measurement technology that detects infrared radiation emitted by objects and converts it into thermal images. Since all objects above absolute zero emit infrared radiation, thermographic cameras can capture this energy to determine surface temperature distributions and visualize temperature patterns effectively. The resulting thermal images allow users to identify temperature variations and detect abnormalities that may not be visible to the naked eye. Due to its fast, safe and non-destructive nature, infrared thermography is widely used in industrial inspections, medical diagnostics, building assessments, and equipment condition monitoring. Next, we will go through explanation of relevant to scientific instrumentation and application concepts. First one is scientific instrumentation. Thermography devices rely on specialized components to capture visible thermal energy and convert it into a visual map. That is divided by 3, which is specialized optics. Standard glass absorbs IR radiation. Instead, lenses are made from materials like germanium or silicon, which are highly transparent to infrared wavelengths. Second one is infrared sensors. Uncooled microbolometers measure changes in electrical resistance as they heat up. They are compact and widely used in commercial cameras. The third one is spatial filters. Isolate specific wavelength to eliminate interference, such as filtering out ambient humidity or looking directly through flames. The second point is core scientific variables. It is to calculate accurate temperatures. The instrument's software must compensate for environmental factors, which is the first one, emissivity, a measure of how effectively a surface emits thermal radiation compared to a perfect black body. Highly reflective metals have low emissivity and require correction in the camera settings to avoid false readings. The second one is environmental compensation. The camera automatically subtracts reflected radiation from the surroundings and accounts for atmospheric attenuation, that is absorption by air, to isolate the target's true surface temperature. And next, for the key application, it is divided by 2, which is the first one, electrical and mechanical diagnostics. It is instantly identify hotspots causes by high resistance, which is in faulty electrical connections and friction, failing mechanical bearings, and it prevents catastrophic failure. The second one is process and chemical engineering. It monitors heat distribution, system reactors, and it also can check insulation integrity, which is can detect fluid levels through thermal stratification. Now I will explain about detailed exploration of thermography technology. Thermography is a technology that uses infrared radiation to detect the measure temperature difference on the surface of object without physical contact. It works by capturing the infrared energy naturally emitted by the object and converting into the thermal image called thermogram. There are 4 main components in the thermography system. First is the infrared lens. It functions to receive and focus the infrared radiation emitted by the target object and direct it to the detector. Second is infrared detector. This component detects the incoming infrared radiation and convert the thermal energy into electrical signal. Third is the electronic processing unit. It processes the electrical signal using image processing algorithm and generate temperature data as well as thermal image information. Finally, the display screen converts the processed signal into visible thermal image, known as the These components work together to allow accurate temperature measure without direct contact with the object. Then, how the thermography works. Before I explain how thermography works, let's watch a short video that demonstrates the working principle of the thermal image.
Ever seen the world through heat? Thermal cameras don't see visible light like our eyes. Instead, they detect infrared radiation, the heat all objects emit. Hotter things give off more infrared waves, and the camera turns those into colors. Usually warm areas appear red or yellow, while cooler ones show up as blue or purple. This lets you see temperature, useful in rescue missions, electrical inspections, even spotting animals in the dark.
From the video, we can see that the thermal camera detects heat emitted from the human body and convert it into different color. Hotter area appear in brighter colors such as yellow, orange and red, while cooler area appear in darker colors such as purple and blue. This allows us to visualize temperature difference that cannot be seen by naked eye. Now, let us look at the process in more detail. All objects above absolute zero, which is minus 270.50 degrees Celsius, emit infrared radiation. The amount of infrared radiation emitted increases as the object temperature increases. In other words, hotter objects emit more infrared radiation than cooler objects. An infrared camera detects the infrared radiation emitted from the object surface. The camera infrared detector then converts the radiation into electrical signal. Thus, the signals are processed by image processing software to create the thermal image, also known as a thermogram, which is show the temperature distribution across the object. In the thermogram, different colors represent different temperature. Red, yellow, and white usually indicate hotter area, while blue, purple, and black indicate cooler area. The thermal image can be analyzed to identify hotspot, heat loss, equipment fault, and abnormal temperature patterns. Because no physical contact is required, thermography is considered non-contact, non-destructive, and real-time temperature measure technique.
What do you see happening in the world today? I sense that people are seeing exciting things in new ways. Exploring new ways to learn and grow. I see efficiency, identifying problems in new ways, and solutions. Finding critical details in new ways. Monitoring changes in new ways. I witness that the world is beginning to see itself in a new way. See the world in a new way.
We go to example of real-world implementations. Thermography is widely used in various industry and applications. The first example is electrical system inspection. Thermography is used to identify overheating electrical components such as transformer, circuit breaker, and switchgear. By detecting abnormal heat pattern early, technician can prevent equipment failure and reduce fire hazard. The second example is building and energy audits. Thermal image help detect heat loss, air leak, insulation detect, and moisturize problem in building. As the result, building owner can improve energy efficiency and reduce energy costs. The third example is medical thermography. In healthcare, thermography is used to monitor skin temperature patterns and detect abnormalities relate to inflammations or circulatory disorder. It provides a non-invasive and radiation-free image method for patients. This example demonstrates how thermography improves safety, efficiency, and monitoring across different fields.
So next is potential benefit and challenge. Infrared thermography has the potential to detect fault and abnormalities at an early stage by identifying unusual temperature pattern before encampment failure occurs. This technology enables non-contact temperature measurement, allowing inspection to be carried out safely without touching the object being monitored. Infrared thermography can improve maintenance efficiency by providing real-time thermal images that help technicians quickly locate problem areas. The technology reduces operational downtime because inspection can be performed while equipment remain in normal operation. Future development and innovation. Future advancements in infrared thermography are expected to improve image resolution and temperature measurement accuracy, enabling more precise thermal analysis. The integration of artificial intelligence (AI) and machine learning with thermography systems may allow automatic detection and diagnosis of fault with minimal human intervention. Infrared cameras are likely to become smaller, more portable, and more affordable, increasing the accessibility across various industries. Future thermography systems may offer enhanced real-time monitoring capabilities through integration with the Internet of Things, enabling continuous remote inspection. So, for the conclusion, infrared radiation technology in thermography is a valuable non-contact method for detecting and measuring temperature difference on the surface of object. By converting infrared energy emitted by object into thermal image, thermography enables fast, accurate, and real-time temperature monitoring. This technology is widely used in medical diagnostic, industrial maintenance, electrical inspection, and building assessment because it improves safety, reduces inspection time, and help identify problems before they become serious. Overall, infrared thermography is an effective and reliable technology that enhances efficient accuracy and preventive maintenance across many fields.